Okay, welcome back. This is part 2 of extraction of metals, where we'll look at extraction of iron. Extraction of iron. Now, in the previous video, we looked at extraction of zinc. And I said that zinc is extracted using reduction method, and the ores of zinc have calamine and zinc blende. Zinc blende is the chief ore of zinc, which is zinc sulfide, and its chemical formula is just ZNS. It's roasted in air to form zinc oxide, and sulfur dioxide. Then the zinc oxide proceeds to the next stage to be reduced by carbon monoxide to zinc metal and carbon dioxide. Then uses of zinc is used in the manufacture of dry cell batteries, in making of alloys, and also in galvanizing iron, last but not the least, in the making of roofing sheets. Let's now look at extraction of iron. Now, if you remember in the previous video, I drew a reactivity series where iron was just below zinc. So they are extracted using the same method, which is reduction. Okay, reduction method. Methods of extraction is reduction what? Reduction method, yeah? Reduction method. Then ores of iron, we have 3 ores of iron, but we are going to be specific and use, we have hematite. Hematite is what? What's the chemical formula? It's iron 3 oxide, iron 3 oxide with the formula Fe2O3. Am I right? Okay. And then we have magnetite, siderite, but we are going to use hematite. This is the main ore or the chief ore of iron. Now, iron is extracted in the blast furnace, which is a tower of about 30 to 40 meters tall. Okay, and it's made up of bricks that have high resistance to heat, meaning they have high melting and boiling point. And the other thing that you need to know is that you have what is called the charge. The charge is a mixture of hematite, which is iron ore, and we have calcium carbonate, which is limestone, right? Limestone, and coke, right? Coke. The iron ore here is the hematite. Okay, hematite. Let me just write its chemical formula, which is just the iron 3 oxide. Remember, the 3 here will go to the other side of the oxygen atom. Then the 2 oxygen has a valence of 2, and the 2 will come here. That's why it's called iron 3 oxide, and the 2 is here. Then limestone is calcium what? Calcium what? Carbonate, CaCO3. Coke is just carbon. Now, these 3 are crushed and mixed together and they are fed into the blast furnace. Now, the reactions are as follows. We are going to start with the coke, the function of the coke in the blast furnace. So when you look at the coke, which is carbon, the function of coke, the purpose of coke is used to what? To form the reducing agent, which is carbon monoxide. And this is done in 2 many stages. Number 1, the coke carbon will be roasted in air to form carbon Very good. Coke is roasted in air to form carbon dioxide. Stage 2, carbon dioxide formed will react with more coke. So carbon dioxide, this carbon dioxide produced here will react with what? Yes, to form what? Carbon monoxide. All right, carbon monoxide. So we formed carbon monoxide, which is a reducing agent in this process. That's all. Let's now go to iron ore. Iron ore. Iron ore, which is hematite. Iron ore, which is hematite, is okay. So which is Fe2O3 reacts with what? Carbon what? Carbon monoxide produced here to form what? Iron and carbon dioxide. Okay, and carbon. Let's balance this equation. Okay, this equation we can balance. This one is easy. These two are easy to balance. Or state symbols. Okay, this is a solid, this is a gas, and this is also a gas. Gas, solid, gas, right? This is a solid, this is a gas. Then the ion formed here is in its molten state. Okay, it's in molten state, which is liquid, and this is gas. Let's balance this equation. This is the most important stage, because that's when ion is extracted. Now, how many atoms of ion do we have on the reactant side? We have 2. How many do we have on the product side? 1. So we'll put 2 here so that ion balances. Yes. On the reactant side, so we go to oxygen. We have how many atoms of oxygen? 4. On the product side, we have what? 2. To make it 4, we are going to put 2 here. Okay, as a coefficient. 2. Let's go to carbon. Carbon is what? How many here? So we're going to put 2 here so that carbon also balances. Then we check. Iron here 2, iron 2. Oxygen 5. Oxygen here. So what can you do? You have 5 here, then here you have 4. We put a 3 here, so you can change both 5 and 4 to 6, right? The closest even now? Very good. So when you change this one to 3, our number of oxygen atoms will be 6, Then here we're going to put a 3 here, so that is 6, Okay, 3 here, so 6, Oxygen atoms balanced. Then we go to carbon 3, carbon here. Okay, let's again go through. Iron here, 2, iron. Oxygen here. Carbon. Oh, so this equation is balanced, Oh, okay. Good. Now we have formed the iron here. What is the function of limestone? Because the whole purpose of the extraction of iron is to form iron, right? Now iron is formed. Now what is the purpose of limestone? It's used to form calcium. How? Oh, so since in the blast furnace there is heat, there is heat. So calcium carbonate would decompose on its own. decomposition, this is when heat is applied. A compound doesn't need to react with another element for it to decompose. It just decomposes upon applying what? Heat. So, we have limestone here. We want to see why limestone is important here, because it doesn't make sense. We wanted to extract iron, and we've come up with iron here, but still have limestone. So we want to know why limestone. So limestone here decomposes. So here you have heat. Decomposes into calcium what? Oxide, right? CaO and carbon dioxide. Very good. Very good. Very good. Now, remember this is an O. Hi? This here, this is an O of iron and impurities. Impurities include what? Sand and others, which is called silicate, right? Or just the sand. Now, the function of limestone is used to remove impurities in the extraction of iron or in the blast furnace. It is as simple as that. The purpose of limestone is to remove impurities. How? But how? When this one decomposes into calcium oxide and the carbon dioxide there, calcium oxide reacts with what? It combines with the sand that remains here to form calcium silicate. Very good. Which is just sand. And that is what we call molten slag. And it has low density. Therefore, it floats on top of molten iron. And it's very important. The floating of molten slag on top of iron prevents oxidation of iron. Prevents oxidation of what? Iron. If this is the blast furnace, let me just sketch the blast furnace here. Here you have hot air in. You can have here out, even here out. So on top here you have molten what? Molten slag. Okay, and it's collected from this side. Then down here you have molten iron, which is collected from this side. Then here you have hot air in, and hot air in is oxygen. Okay, is what? Oxygen, which is used to heat the blast what? The blast furnace. All right. So purpose of molten slag in the blast furnace is to prevent oxidation. Now, here you have outlets here where you have waste gases, Waste gases, you have waste gases such as what? Carbon. What is the uses of carbon dioxide? Let's just be realistic. Carbon dioxide in general. What is the use of carbon dioxide in general? Plants use it to for what? Photosynthesis. Okay, you are right. You are right. Plants use carbon dioxide and water to form what? To form oxygen and glucose, right? That is called photosynthesis. So carbon dioxide, which is one of the waste gases, is used in the what? Is used by plants to, yes, photosynthesize. All right, so we have other uses, but let's just stick to that. And then let's look at uses of molten slag. What do you think are the uses of molten slag? Number one, oxidation of iron. Apart from that, it's used in the manufacture of cement. Apart from that, it's used in the construction of roads. Yes, exactly. You are intelligent. Then iron. Now the iron here, we can't just look at uses of iron here, because the iron that is collected here is not pure iron. It is called pig iron. Pig iron, the impurest form of iron, is not pure. Now, the purest form of iron is called what? Wrought iron. This is the spelling. Wrought iron. This is the purest form of iron. Then, so after extraction here, after you collect your molten iron, the iron has to go another process to purify it. Okay, so iron is used to make alloys, such as what? Alloys of steel, nickel, and the other. Stainless steel. You have milled steel. Milled steel is is the alloy that is used in the manufacture of car bodies. You get it, huh? Yes. Stainless steel is used in the manufacture of what? Okay. Kitchen what? Utensils, or surgical instruments, and many others. So now, extraction of iron will not be complete if we will not talk about corrosion of iron. Corrosion of iron is rusting of what? Rusting of iron. Now, when you look at rusting of iron, this is the corrosion of iron, or this is the what? Decomposition of iron when the iron is exposed to oxygen and the moisture, which is water. Reddish brown is rust, Yes. Rust is reddish what? Brown, which is formed when iron is exposed to oxygen and that's the conditions. Two conditions for rusting. This is oxygen and the water. Aye. Oxygen and water.
What do you call the process by which iron is exposed to oxygen?
The process by which iron is exposed to oxygen, okay, oxidation, by which oxygen is added to iron. That is called oxidation of what? Iron, Very good. And let's look at prevention. Methods of what? Rust prevention. If you've followed me from extraction of zinc up to now, one of the uses of iron is there. What do you think? What uses of iron? Methods of rust prevention. Number one is What is galvanizing? Making it strong. Okay. This is when a reactive metal is used to what? To protect a less reactive metal from corrosion. For instance, if you look at zinc, iron is just below zinc here on the reactivity series. So then this iron can be protected by zinc when you coat it. When you coat this, iron is Fe, not Zd. Fe. When this one is coated with what? Zinc. That is galvanizing. Using a more reactive metal to protect a less reactive metal. That is galvanizing. So it's almost time up. Let's just conclude on. So there's oiling. Very good. Oiling prevents the entry of oxygen and water, right? If you try to apply Vaseline on your skin here, you find that water doesn't stick, right? Water doesn't stick. So you can apply. Also, there's oiling, electroplating, there is galvanizing. What else? Painting, Yes, painting. What else? Okay, that's all. All right. So, all the best. We've just looked at the extraction of metals. Then probably we may look at acids, bases, and salts. in the next video, of which will be